So I wanted to talk today to you about something that I'm super personally passionate about, which is people-first engineering. And I'm going to try to give you some background into like the history of my thinking about this and why I think this is important and why I think this should be important to all of us as engineers. But I'll give you a little bit of background about myself first. There's this sort of basic who am I question. My name's Blake Irvin. I'm an American, if you haven't figured that out by now, by my unique accent. I studied fiction and poetry in university, so that's what my degree is in. So I am one of those people who has a liberal arts degree who works in software engineering. And I do stuff now with computers to make people's lives better. I currently work for a startup in Berlin called SmartB. So SmartB does energy management and transparency analysis for businesses and enterprises. So we kind of put like a little embedded Linux device onto the power grid of a customer's facility or their building, and we sort of listen to the devices that are on their power grid and help them figure out which devices are being wasteful and where they can save money and where they can save energy. So we're really sort of a sustainability startup. So I want to start with a little bit of sort of the history of what people-first engineering means to me, and I want to do that by starting with a story. And so as an engineer, especially, well, this is still true, but one of the original reasons that I started doing engineering work is because I wanted to use technology that I thought was interesting or cool to make other people's lives better. And this first story goes way, 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 way back to the days when this was still a common operating system. How many people remember OS 9? Anybody used this before? This was like for a long, long time, this was like the cutting edge operating system, and then after a while it wasn't anymore. So in the beginning of my career, which was about almost 15 years ago now, I guess, I was doing a lot of consulting work for design companies and these like marketing companies and people who are using Macs, because the company I worked for was a Mac consulting company. And we had a customer who was actually, I think, making labels for canned goods. So they were like making the labels that are printed on the outside of the can. And they were using InDesign to do that. And after a while, a point came where their printers could no longer accept files that were generated on the OS 9 version of the Adobe software they were using. So the agreement was that I was going to come and I was going to upgrade them to OS 10. It was going to be Unix. They were going to have multitasking. They were going to have process scheduling, all this really cool shit that nobody had ever seen before in the design world. I was very excited. I thought I was going to make their lives way, way, way better. And so I came into the shop and said, okay, like to the designers, especially the lead designer, I said, look, don't worry about this. This is going to be super easy. This is going to be great. You're going to love it when I'm done. Go to lunch. I'm going to do the upgrade. I'm going to migrate all your settings, going to bring all of your software into this new system. And when you come back, it's going to be great. At least that's what I thought. Because upgrades are exciting, right? I'm an engineer. We're all engineers. Most of us think that the new version of something is better than the old version. I was very excited about this. Couldn't wait to see how happy they were. But the actual reaction that I got was this. My customer came back, sat down in front of the machine. We booted it up. They burst into tears, like they were literally crying in front of me with their face in their hands, and said, "Fuck, I hate change." So this really kind of like made me take at least one or maybe like 5 steps back mentally, because the thing that I expected to happen had not happened at all. The customer was not happy. And I realized it really made me think about what the purpose of my work was. Like, was I here to upgrade software or was I here to help people? And I realized that something that I was missing at that point was empathy. Not that I didn't believe that empathy was important, but I wasn't putting myself in the shoes of this customer at this point. I wasn't thinking about what their life was going to be like after this upgrade. And this is something that stuck with me since then, and I keep coming back to this theme as an engineer of empathy, the importance for us as engineers to be thinking about what our customers feel and what our colleagues and teammates feel and the people in our tech communities feel about what we're building. So empathy is literally, according to the Webster Dictionary, the ability to understand and share the feelings of another. But the important thing about this is that the another in this case is a person. And what I found in over the course of my career, which is not like the longest career ever, but it's been more than a decade, is that this priority on empathy is what separates the best engineers from the rest. The very, very best engineers that I've worked with, almost without question, have been empathetic people. People who are thinking about not just the features of what they're building or like the excellence of what they're building, but they're thinking about what it's going to be like to be the person using this tool or using this technology that they're creating. So, and this has led me to think over the years as I've worked with various teams about the sort of like positive patterns that we can adopt that sort of bring us towards a more empathetic view of engineering. These ones, the patterns that I'm listing here are ones that I think really apply the most to what we do inside of teams. So when we're working with our colleagues and we're working together as teammates, how are we empathetic to each other in the team? One of the big ones, I think, is to give autonomy to the implementer. So this is, like, how many of you do Agile or Scrum, something like that, right? So like there's this concept of self-organization in Scrum, which is really important, and we're supposed to be self-organizing. In reality, what happens a lot is that the person who's in charge tells everybody else what to do, right? Or we're like, no, you can't do that. We don't do things that way here. You have to do it this way. The problem with that approach, I think, is that there's like no empathy there. You're not thinking at all about what it's like to be the person who's actually down in the shit, dealing with all these bugs and trying to fix things. So I think what I found is that it's an incredibly powerful tool to say, if you're doing the work, I'm going to let you have autonomy about how you do that work. The details are up to you. You're dealing with the implementation, because we understand as empathetic team members that it's the other person that has to deal with all the pain, and we're going to give them the freedom to deal with that however they want. I also think it's important, this is especially important as we do inspection, or we try to maybe let's say you're a more senior team member and you're coaching somebody who's less senior or just less experienced in a subject area. When we're coaching them through the process of improving their code or improving a product or a tool, it's incredibly important, I think, to use this Socratic method, which is to say we want to ask questions and not make statements. For me, and I think I'm a pretty typical engineer in this way, I really like knowing the right answer. I like knowing what's going on. I like telling people what to do, or at least telling them what the correct answer is. It's much, much, much more powerful to ask questions. Partly because it helps us, right? Even if we think we're the expert, as we ask questions to help other people learn, it also helps us to learn as we do that. So a useful trick that I've discovered is just, whenever I want to say something and I want to say it as a statement, try to think of a way to say it as a question. So maybe we don't want to try to use Redis for persistence. Maybe we really want to use Redis for sorting. Maybe it's better for sorting than for persistence. Something like that, which is an actual conversation I've had a few times. And then, of course, there's going to be times inside the team where we actually start debating about stuff, right? We're disagreeing with each other, sometimes very heatedly, because we're engineers and we want to do it the right way. We're disagreeing, and we need to find a way to resolve those disagreements. And here's where, again, if I think about this empathetically, if you have this discussion happening, let's say you have a team of 8 people, and there's one or two of those people that really, really, really feel like you should do it way X, and you kind of feel like, based on your experience, that Y is better. But they really, 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 they love this idea of doing thing X. In the long run, just let them do it. Let the people who are passionate do what they want to do. And they may be wrong, and you may have to come back and fix that later. But at least you've given them, you've gone back to this autonomy concept, and you've given them them sort of the trust that they need to do what they want to try to do, and you've fed that passion and let the passion grow and turn into something bigger, instead of killing it and sort of forcing them to do what you want. And that's why I say here that it's so important to say I trust you. I've been in a couple of shops actually where we sort of officially introduced as a policy that we need to say I trust you when we disagree with people, right? So if we've got let's say you're doing pair programming, a pair decides I'm going to try to fix this, or I'm going to try to make this improvement or fix this bug. Even if you have caveats or some reservations about what they want to try to do, at the end of the day, they're your teammate. Actually say the words I trust you, and whichever your office language happens to be. So if it's not English, say something else. But say I trust you to that person. Because this is, again, something that's, in terms of like we think that we're building software, but what we're really doing usually is building teams. The software is an outworking of the team, right? And this trust between team members is something that's incredibly powerful, and you will see like huge changes in the way that you do software development and the way you do systems development when you start doing this. So then there's also, I think, some empathy patterns about how we do the actual implementation itself. So how we actually do the building of the thing. A big one here is empathizing with your future self. I saw Mario walk in just a second ago. Mario and I, when we worked together, did a lot of this discussion, right? Like, yeah, we're going to build this, and this is really going to suck in like 6 months, right? Like, we're going to come back to this, and we're going to hate ourselves for doing this. So it's important to be kind to yourself and to think about how this is going to feel for yourself in the future, not just about what's going on at the moment. There's some really, really sort of obviously simple things we want to do too. Like when we make command line tools, we want these to be self-documenting, because in 6 months we're not going to remember what we did. We're not going to remember what the flags are for this tool or something like this. There are some very good examples out there. There are some less good ones. But if you think about the tools that you really love using on the command line, most of them, I think, are self-documenting. When I talk about self-documenting tools, I'm not talking about find, and I'm not talking about tar. And I also think that when we talk about how we do sort of like architecture, and the architecture being a word that I'm a little bit it makes me a bit nervous when I hear it come up in conversations in organizations that I've worked. But if we're going to talk about the architecture of software, I think trying to build things so that we can start in the repo, like start with the code, and figure out what's going on from there is very important. When I've been in organizations where, you know, on my first day, I come in and someone tells me to go look at wiki pages, that immediately makes me get nervous, because the wiki is always out of date. The stuff in the wiki is always wrong. Sometimes it's not even close to being right. What I would much rather hear is, here's the repo for the project that we're going to start working on today. I can get into the README. The README kind of gives me a high-level overview, and I can sort of start at this trunk of the software tree and work my way out into the branches. Because when you, and if you think about this tree climbing metaphor, right? Like if you're climbing a tree, you don't want to start climbing at the top of the tree. That's very dangerous, because that branch might not be big enough to hold you. Or there might be thorns or something. What you want to do is you want to start at the trunk of the tree, and you can figure from something that's sort of small and easy to reason about, you can work your way up into those branches. And that's another piece of empathy. Like we want to be empathetic to ourselves and to future users, and we want to remember that when we get into, let's say, like an emergency situation or there's firefighting going on, we want to have a stable, safe, easy to think about place to start. So I'm talking about software as a tree, right? And it's obviously not a tree. So what am I doing when I say that? What I'm doing is I'm using a metaphor. And metaphor is something I've been interested in since way, way back in my university days, when I did a bunch of research projects on metaphor in a very abstract sense. But metaphor actually turns out to be super important for people who work in abstract fields like software. And a metaphor is, by definition, a figure of speech in which a word or phrase is applied to an object or action to which it is not literally applicable. And this isn't a metaphor. This is a guy. This is a guy named Jake, who is a former colleague of mine, and also way, way back when I first got out of university, he was my first roommate. And does anybody know what these machines are? Can someone identify those? This is where I start to feel like I'm an old person in the room. Those are PDP-11s. Those are some of the first really popular DEC mini computers from the 70s. Those are 3 out of the 6 that we had. How many people have used a PDP-11 before? So it's just me. How many people have had a PDP-11 in their room before, in their bedroom? Just me. Okay. How many people know how hot it is in the summer if you don't have air conditioning and you have 6 PDP-11s running in your room? Yeah, it's very hot. So you don't want to do this. Like, don't do what I did. But anyway, so Jake and I were roommates. We didn't have a lot of space in our flat. I had the PDP-11s in my room. And Jake decided, well, you know, since you have PDP-11s in your room, you might as well learn what Unix is, which I knew nothing about Unix at that point. All I had ever used was Windows and some Mac, like early pre-Unix Mac stuff. But the genius thing that Jake did when he introduced me to this big, complex world of things I had never seen before was that he only talked about Unix in terms of metaphors. He never started with, okay, so the bits flip like this, and then the transistor does this. He didn't do any of that stuff. He started when, for example, explaining to me how TCP networking works, talking about TCP clients and servers talking to each other the way people would. So he was only using metaphorical language. And that was a super powerful mechanism for me, as someone without a formal computer science background, to get into understanding how this stuff worked. And I kind of was able to work my way back from the metaphor back to the actual physical workings of the system. So I would argue that metaphor is, because we're humans, right, because we're not machines, metaphor is one of our most powerful ways for reasoning about abstractions, especially when those abstractions are new to us. It's a map that we make of the abstract world. So there are certainly some metaphors, or there are certainly some phrases that we use that are very abstract that now mean something to us, like when we say API, most of us kind of instinctively know what that means. But generally speaking, we use metaphors constantly to talk about the abstract systems we're working with. So here's an example. So all of these statements are true, right? I can say an object, like my fist is an object. I can say an object as in object-oriented programming is not an object. It's definitely not my fist. But I can also say that an object-oriented programming is an object, right? Because it's a metaphor. It's a way of I'm thinking about how there's this encapsulation of logic in this object, and I'm passing it around the way that I might pass an apple around the room. And specifically, I don't want to. We could talk about metaphor for like the rest of the week if we wanted to, possibly forever. That would lead us into like artificial intelligence research and all this other stuff. Don't want to do that. I want to just stick with a very, very simple way in which we use metaphors in computer science, and that is naming things. Because I think names are probably the most common metaphors that we use in software. So here's some common ones. We have like a gem. If you're a Ruby user, it's theoretically useful, valuable Ruby code that's in a small package, right? We have GitHub. It's a central place, a hub where we can come and share code and interact together. Docker is a way that we can manage and store containers, kind of the way that a ship that holds containers would dock in a harbor. So these are metaphorical ways they're ways of us thinking about these abstract concepts metaphorically so that we can think about them quickly. So there's this joke about the two hardest problems in computer science, which I'm not going to tell. But part of that joke is about how hard naming things is, right? And I would say that one of the biggest reasons that it's hard to name things is because this requires a lot of empathy. For example, for me as a monolingual English speaker working in Europe, it's incredibly difficult for me to figure out how to name things effectively when I'm working with teams where everybody else speaks English as a second or third language. That makes this process much more difficult. Not that it's less valuable, it's actually even more valuable in that case, right? Because we're all sharing, in most cases, not our native language. And we really need to find words that symbolize what we're talking about and do that effectively. So what are some patterns for naming things? Because I think the joke that I was referring to really is true. It is very difficult to name things effectively when we're doing programming or we're doing software stuff. And the fact that it's hard means that it kind of indicates that it's important as well, I think. So what are some ways that we can name things better? So the first thing I think is we can just name things what they are. I know that sounds ridiculous to have to say that, but I have been in so many shops where there's a piece of software and it is named something completely different than what it actually is. I think the first startup where I had like hundreds of millions of revenue that I was dealing with, our database, our MySQL database, was called TestDB, right? So that made it incredibly difficult for us to talk about the actual TestDB that we were using in a lab situation versus the TestDB that we were using in production. I just finished working on some stuff in my current gig where we had our API was called Web Backend, which means essentially nothing, and finally got the repo name changed to API because it's an API. That's what it is. All of our front end stuff is Angular. It all talks to the API. It's also important to just be mnemonic, right? Like sometimes we come up with great names, but they're very, very hard to remember. I love Pivotal Labs, but I still cannot remember the name of their continuous integration workflow tool that they released like last year. It's not Confluence, it's like Convergence or Conway or something like that. But I can never remember what it is. So we want to make sure that they're names that we can remember. This is a big pet one for me, avoiding acronyms. I fucking hate acronyms. The only acronyms that I can stand are the ones that are so common that they mean something to us already. So API would be a good example. In my mind, API as an acronym has been around for so long that we just know what it means. But in the specific field that I work in, like energy management, we have this acronym called NILM, N-I-L-M. It means nothing. Like, not even to people who work in energy management does NILM mean anything. So I've been trying to root that out of my my current job as much as possible. So the problem with acronyms is that we have to always have a map of what they mean. So we're trying to solve a problem quickly. We're trying to communicate with new hires. We're trying to communicate to potential hires. Just thinking in general just takes longer if we have to constantly be mapping acronyms to something else. And we're out of the 8-bit era, right? So we can use long flags. We can name things whatever we want. We don't have limits to character length. We're also in the post, like everybody's sort of accepted GNU double dash flags, so we can have long flag names as well. And this is still empathy, right? Like we're still remembering that either we in the future or some other poor person in the future is going to have to use what we've built, and we're not going to remember things. And if we have to go look up what the acronyms are, we have to go look up what, like we think that -Q means quiet, but it actually means quit, right, as a flag. That's bad. Like we don't need to be doing that to ourselves. We can name things what they are, and make lives much easier for everybody. So I'm still talking here about empathy, and why is that? Why is empathy so important? Like, so I'm saying that it's important, but I'm not really saying why it's important philosophically, and I think some philosophy for this is also very, very necessary because it's why we do things. And this is why. So this is a very weird example, and I could not find a better picture. But what's important about this is a South Indian restaurant I used to go to all the time with my boss at my first cloud-enabled startup. Right, we were like super early AWS adopters back in like 2006 or 7, trying to run fake financial transactional workloads with like virtual currency in AWS way back then. Very, very, very difficult. Don't do it. So we used to go to this restaurant all the time, and when we would sit there and we'd talk about work and we'd talk about what was going well or what wasn't going well, and sometimes we'd just be looking around, and I realized there was something really special about this double door, right, that went to the kitchen. And this is what was special about the double door. What was special was that the hinge that held the double door in place, that closed itself, was not like any other hinge I had seen before. It didn't have a spring. It didn't have a hydraulic actuator. It didn't have anything like this. All it had was, if you can imagine that my arm is the top of the door, it had this hook of metal like this, right? Like this, right? And the door was hanging from another loop of metal like this. So when the door opened, this hook of metal rode up on the other one, right? And then the force of gravity would pull it back down into place. And I can describe this in more detail to somebody afterwards if you can't see my hands too well. But the point is that the entire mechanism was completely self-operating, self-cleaning, didn't need any maintenance, was dead, stupid, simple, and would never break. Would never, ever, ever break. And what's important about that, I think, is, and this is where the empathy piece comes in, you kind of have to follow me down this weird connection of concepts here, but the person who built that door, intentionally or otherwise, was protecting the most valuable resource that we have as human beings, which is our potential and our time. Because nobody at that restaurant had to fix that door, and nobody had to fuck with it, they were able to worry about running the restaurant, dealing with customers, doing things that actually mattered, right? And whoever invented that door hinge was in some way an engineer, just like we're engineers. So when we do the same thing, when we remember how important human potential is and how valuable the time that our users and our colleagues is when they use our stuff, we're protecting that, and we're being empathetic when we protect that resource. This is something one of my CTOs said right as he left to go pursue something else. So he was kind of like, let's get coffee before I leave. I don't really want to give you advice or be too emotional about this, but I'm going to miss you, and let's get a coffee and chat. And then the one piece of advice he gave me was this: you can always get more money, but you can never get more time. So don't waste your time. And I think that this, at first I thought he was just talking about me personally, like, what am I going to do with my life? Am I going to be wasting my time personally? But really, I realized much later, just like the way that door is designed, that door saves time. Time is the most valuable resource. What we build, when we build it well, and when we build something that keeps us from wasting time or other people from wasting time, that's incredibly valuable. Or another way to say it, this is from one of my favorite novelists, Ursula Le Guin. One of her characters says, "Do nothing because it seems good to do so. Do only that which you must do and which you cannot do in any other way." And this one, when I read this the first time, the engineer part of me kind of got a little bit upset, right? Because of course I want to do cool stuff. Of course I want to try new things. But I realized as I read it that it connected back to the same idea about protecting human potential, right? Like, I don't want to do unimportant things. I only want to do important things. And I need to figure out what those important things are and minimize the time I spend doing busy work. And it's not just me. It's also the people that are using what I build. I don't want to be wasting their time either. So then I guess the question is, what must we do? And I think a lot of that one of the ways that we as we struggle to answer that what must we do question, we think of things like the KISS principle, keep it simple, stupid. But there's also, I think, patterns towards this simplicity that we can try to embrace or achieve. So I think, first of all, we can embrace simple tools, right? Like, if there is already a tool out there that does what you need it to do, just use that tool. Like, we don't need to reinvent things. Real reinvention, especially, I think, at least for me, the longer I've been doing this kind of stuff, the less interested I am in real reinvention. Like, the wheel works, or whatever the tool is works. I still use tar almost every day for the system stuff that I do, because tar just works. Yes, the flags for tar suck. It's very hard to remember which flags to use, but tar works. I also think that it's important for us to sort of study and mimic natural systems. There's a field of study called Emergent Systems, and one of the sort of classical natural world emergent systems is like a bee or an ant colony or a flock of birds. If you think about how an ant colony interacts, right? So you have a bunch of ants. They're fairly simple creatures. They always do a certain set of preset actions, and they communicate to each other in a standard way all the time, which actually sounds a lot like Unix philosophy or services, right? So it turns out actually that the things that we use when we build systems or software, the things that work really well, it turns out that they mimic simple natural systems. These systems don't always have to be simple, but we try to be as simple as possible within reason. And I think also we find that if we invest in simplicity now, we get a lot of dividends back from that later, right? So we're trying to be empathetic about our own potential and the potential of people who will be using our tools later. We're trying to be simple so we can protect that potential and protect people from wasting their time. And simplicity can really help us there. And if you haven't done it, if it wasn't such a cop-out, I would have just had us watch Rich Hickey's Simplicity Matters talk. Or Simple Made Easy talk. This is an amazing video. Like, if you have not, how many people have seen this video already? Right, so a couple. Like, if you work in software, you must watch this video. That's the only like right and wrong thing I will say, is that you must watch this video, because everything Rich says about simplicity and why simplicity is important has just been proven to me and everybody that I know that's seen the video just over and over and over and over again. So I'm being a little bit. I'm defining simplicity a little bit more broadly than Rich would, so apologies to Rich for that. But the talk is amazing, and it will just stay with you as you build things in the future. So you might say, and this would be a completely fair sort of point to raise, that real projects are messy, right? So here it's Blake, and then Blake's telling you to be simple and have everything be separated and everything be services or separate programs or something. But real projects are messy, right? And that's true. But I think there's some ways that we can sort of iterate our way from the mess and complexity of a new project into something better later. So there's this, does everybody know what the cathedral and the bazaar are? Are you familiar with that term? So there's this sort of like eternal debate in software design, systems design, about whether we should build perfect systems that are these cathedrals that have the central architectural plan, or if we should just iterate like a bazaar and just try things until something works and let the right answer sort of evolve out of that mess. I don't think that there's really a right or wrong answer there. I think in reality we sort of start in one place and move towards another, or we have a hybrid after some time passes. So what I've personally found that works well here is that while we're learning, so like at the beginning of a project when there's a lot we don't know yet, let's just allow the bazaar to happen. Let's just accept that there will be some mess, and we'll try to learn. And as we learn, we can start to iterate toward task-specific cathedrals. So like a good example of this would be when you talk, or like a good practical example of the cathedral and bazaar debate would be, do I build a monolith or do I build services, right? You can go the wrong way either way. You can build way too many services at the beginning, or you can build a monolith that really sucks too. In reality, what will probably happen is, as you iterate and you learn, you'll find, oh, I actually built more services than I need, right? Like there was a group I worked for a few years ago where we had an inbox service and an outbox service. I was never able to figure out how that happened, like why we didn't just have a messaging service, but that's what we had. We eventually realized that was wrong, like not the best, and sort of like moved back towards something more monolithic. But you'll adjust your way through this as you learn. And what'll happen, I think, and what I've noticed is that as you get better at this and as you start to understand your workloads and your customers better or your needs better, you'll continue to have these new projects which are bazaar projects where there's a lot of mess and complexity and things kind of tangled together. But you'll be solving some of those problems with cathedrals you built on the last project or cathedrals you discovered that are in the community. And so that's sort of a way of iterating towards that goal. So iterating your way out of complexity and into simplicity. So I do want to tell one more story. And that one's about a CTO that I had. By the way, bonus points if you can identify this movie in 10 seconds. Okay, so we got one. Good. Very good. Very good. Yeah, so I had a CTO who at one of my very, very early stage startups in San Francisco, he was spending all of his time for the first couple of weeks just setting up pairing stations. So we had like 10 or 15 developers crammed into a tiny apartment in San Francisco, and my CTO was like setting up people's computers. And I couldn't figure out why that was, at least not at first. But what I realized eventually was that he understood that the team's potential was much more important than him playing CTO, right? He had the humility to realize that his job was to be an enabler and not to be somebody who was like, making important calls and driving fancy cars and stuff. So, and humility, I think, is something, this is kind of like the last big theme after this like empathy and simplicity. Then there's this humility theme, I think, for people first engineering. Humility is not a popular concept in the tech world. We don't hear a lot of talk about this. We hear a lot of talk about being a rock star or a ninja or a superhero, but we don't hear a lot about humility. But I think this is a far more powerful philosophy to hold on to than those other ones. So what are some patterns that we can follow towards better humility as we work? And a lot of this has to do with teams, right? So how many people are doing pairing? If you're doing pair programming or pairing at all? Okay, so not... Okay, so I would love to see every hand, at least. I would love to see everybody doing this at least sometimes, because when you pair, you really, really, really learn to be humble as an engineer. And you learn what you don't know, and you get a chance to teach other people, which is also great. And when you're pairing, I think it works really well to let the less experienced drive. This is extremely difficult to do. It's very, very, very hard for me when I'm pairing to let the person who doesn't know what's going on do most of the typing, but it's very powerful when we do that. Because being ready to help is much better than knowing everything, right? And much better than telling people what's true. If you help them to think their way through things, you end up with a team where everybody knows something about everything instead of just a bunch of experts, and you have to always be blocking while you're waiting for someone else to tell you something. So there's also some sort of, those are sort of outward-facing humility things, like how we're humble with the people we work with. But there's also some that are sort of inward-facing, or that can either be inward-facing individually or inward-facing for teams. working hours deployments, that's not just because we're lazy, right? I don't want to deploy during the day just because I'm lazy. I also want to do it because I know that I will mess up if it's late at night. I started my career doing 1 a.m. deployments. I don't do that anymore. It's not because I'm lazy. It's because it works much better to do things when I'm awake because I make a lot of mistakes. Same with the self-documenting programs we mentioned before. We will forget things. We should expect to forget things. That's okay. We should build things so that forgetting things is okay. We should build systems and tools that are safe to operate. And personal, this is a big personal thing for me, is I love seeing good code comments. I love seeing good code comments. And the reason for that is that even if it's code base you work on every day, you're not going to remember what this stuff is in 3 or 4 weeks. You're always going to forget why you did something. Code should not be about showing what an amazing array iteration you can do as a Ruby developer or something like this. It should be about maintainability and readability and your future self being able to come back to that code and see what's going on, or some other person doing the same. We should also, when we design systems themselves, we should make sure that systems are user interruptible, right? So this comes from Margaret Hamilton, who wrote most of the code for the Apollo missions back in the early days. She kind of pioneered the idea that, oh, gee, maybe the systems we build, maybe we're fallible and we're not going to think of everything, and we should make the systems user interruptible, because if we don't, these poor astronauts in this tin can are going to die on their way to or coming back from the moon. We also want to make sure that those user interruptible knobs and levers that we build on those systems, we want to make sure that we understand them before we automate. So when we think about that automate all the things meme, forget that. We don't want to automate all the things right away. We want to understand the way things work first and then automate what we understand. Because machines are very good at doing repetitive tasks, but we are not good at telling machines how to make choices. It's much better for us to make the choices and to make sure that we build the systems in such a way that we can make those choices when necessary, rather than, unless you're working on Google's self-driving car project, you probably don't know how to make a machine make a good choice. At least I don't. And if you're a leader, if you're leading, you have to be extraordinarily humble, right? So I've been lucky enough to be leading a few teams at various times. This is the hardest part, because if you're a leader, you feel like you need to be the person who knows everything and the person who's got all the answers and can tell everybody what to do at the right time and in the right place. But the reality is that's not what it is. What you really are as a leader is an enabler, right? So you want to be helping your team to embrace compromises when there's disagreements, and you want to be helping your teams embrace experimentation instead of having like right or wrong answers. Generally speaking, there are no right or wrong answers to these things. We're just trying to solve problems, and we're trying to do them in the best way possible at the moment. So as a leader's, humility is super important. So let me sum up. We're here to help people. This is especially important that we remember this, because as engineers we have this huge multiplier effect. This is way beyond just this, the superstar engineer 10x, 25x multiplier effect. That's just talking about software. When you also think about the multiplier effect you have on the teams you work with or the people who use your software, it becomes even bigger. You could have millions of people using the software that you're writing. And we're human, so we really want to, and the people who are using this stuff are humans, so we want to protect and maximize that potential. So for me, this whole concept, this whole people-first engineering, always putting people first as I think about how to do things or what to do next, it's incredibly powerful as we iterate and as we build our software. And I think if we're honest with ourselves, I mentioned rock stars and ninjas before, this is not really what we need, right? Especially like this sort of hero thing, you only need heroes when shit gets really bad. What we really want is to build a world where the software that we are using is not breaking all the time, and we're not constantly pouring all of this human potential into this black hole because things are so fucked up. What we really want is thinking more like gardeners or teachers or farmers even, right? We want to have that cultivating attitude where we have like a community of people working together to create something together. And I think, at least for me, that's like the vision that I have of the future of engineering, so that we can actually put engineering in the same list, and it can have those same beneficial and positive connotations. And I would be remiss if I didn't put a list up of all the people and organizations of people that have influenced me as I think about this stuff. So that's all I have. Thanks a lot, and enjoy the rest of the conference.